Alright, so we're going to be looking at present value of annuities. Commonly, we're going to be looking at taking out a loan and then seeing how much our periodic payments will be. Or we're going to be looking at, if we have a bunch of money in an account, how can we draw money from that account over time periods. So let's look at this example and let's fill in some information. So if we're making monthly payments of $245.64, we're going to be able for 4 years to repay a loan at 7.2 compounded monthly. So let's first look at what our payment is equal to. Our payment is equal to negative 245.64. So that's with this value right here. Notice it's negative, and that is because $245.64 are leaving us. So to indicate that cash flow is going outwards, we have to denote that that's a negative. Our per compounding interest rate will be R divided by M. In this case, that's 7.2 divided by 12. Because we're making monthly payments, our M is equal to 12. And the number of time periods we're going to have, that's always M times T. In our case, that is 12 times 4, over 4 years. Alright, given that we now have 3 bits of information, we have a payment, we have what our I equals to, and we have what our N equals to. We then can compute for the present value. What is the present value given this information? And our present value, when we compute for using our financial calculator, equals $10,218.33. So if we wanted to take out a loan for $10,000 and $10,218.33, we're at an interest rate of 7.2 compounded monthly over the course of 4 years. Our monthly payment is going to be $245.64. All right, let's look at another example. If we're making semi-annual payments of $3,200 are made for 12 years to repay a loan at 9.9% compounded semi-annually. Once again, let's calculate our payment. Our payment is negative $3,200. Our per compounding interest rate is always R divided by M. So in this case, 9.9 divided by not 12, but 2, because it's being compounded semi-annually, then our M is equal to 2. Also, our N will equal to M times T. So in this case, it's 12 times 2. So now we have 3 bits of information: our payment, our per compounding interest rate, and the number of compounding periods. And once again, we can compute for what does the present value equal to. If you compute for the present value equals to $44,371.22. Alright, let's look at a little word problem. So American General offers a 7-year ordinary annuity with a guaranteed rate of 6.35% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $10,000 annually over 7 years? So in this case, we're going to be receiving payments of $10,000 annually. So that is telling us that our PMT equals to a positive 10,000. To calculate I is our annual interest rate divided by M. So in this case, 6.35 divided by 1 because it's compounded annually. To calculate for N equals to M times T. In this case, it's a 7-year annuity compounded or received annually, so it's just going to be 1 times 7. And now we have 3 bits of information. We have our payments, we have a per period compounding interest rate, and we have the number of payments we're going to be receiving. And then we can calculate for the present value. In this case, the present value equals to negative $55,135.98. So we would have to pay $55,135.98 in order to receive $10,000 every year for 7 years. All right. If we have the annual interest rate on a credit card is 16.99%. If a payment of $100 is made each month, how long will it take for an unpaid balance of $2,487.56? So, when we see this unpaid balance of $2,487.56, you can think about that as receiving $2,487 of $2,487.56 today. So in this case, our present value equals to a positive $2,487.56. All right. To calculate our per period interest rate, that is our annual interest rate divided by M. So 16.99 divided by 12. And then lastly, we know our payment equals to negative $100 because we're making payments of $100. We're going to have our payment be negative $100. So we have 3 bits of information. We know the present value, we know our per period compounding interest rate, and we know our payment. So we can calculate for what does n equal to. And once we calculate for n, we'll get n equals 31. So what does 31 represent? 31 represents the number of months that it will take for us to pay off our debt. So 31 months is t equals 31 divided by 12, which equals to 2.523 years. All right, let's do one more example. A recreation vehicle costs 80 grand. You pay 10% down and immortalize the rest with equal monthly payments over 7 years. If you pay 9.25% compounded monthly, what is your monthly payment? And we want to know how much interest will you pay. So first, let's figure out what our loan will be about for. If the car costs, the recreation vehicle, the RV costs 80 grand, and we paid 10% down, that means we need a loan for the remaining 90%. So 80 grand times 0.9 equals to 72,000, which equals our present value. So that is the size of the loan that we need to take out. The per period compounding interest rate will be IR divided by M. In this case, it will be 9.25 divided by 12. And N will equal to M times T, which equals to 12 times 7. So now we know 3 bits of information. We know the size of the loan. We know our per period compounding interest rate. And we know the number of compounding periods we have. So we can calculate for what will our monthly payment be. We calculate for PMT. And we get PMT equals to negative $1,167.57. So our monthly payments will be $1,167.57. It's negative because that's indicating that we are losing. We have to give up that much money each time period. So that was the first question. So what will our monthly payments be But we also want to know how much interest we paid. Well, note 12 times 7. We have 84 payments of $1,167.57 equals to $98,075.88. So that means over the course of the 7 years, we gave up $98,075.88. That would be the sum of all our payments equals to. Now note, if our loan was originally for an even 72 grand, if we subtract our original loan from how much we paid, then we know how much we would have paid just in interest. So we would have paid just in interest $26,075.88, and this is how much we paid in interest. So just so we can take out a loan to pay for this RV, we paid $26,075.88 or over $26,000 just in interest alone. All right, so that does it for today.